Hello students, welcome to CM Hub, where you, me and chemistry connect together. This platform is a gateway for mastering chemistry. Now let us look at the next question, where we'll be again discussing about the concept of stoichiometry. This question was asked in NEET 2024. Let us look at the question first. Which reaction is not a redox reaction? You are given 4 options. Among that, one of them is not a redox reaction. What are the concepts that you require to solve this problem? The first thing that you need to understand is what is meant by a redox reaction. Redox reaction is a combination of 2 terms. One, red, which implies reduction. Second, ox, which implies oxidation. Reduction and oxidation take place simultaneously. If forward direction is reduction, backward direction will be oxidation. If forward is oxidation, backward is reduction. They always go together. So let us first understand what does the word oxidation mean. There are 3 different definitions. 2 are old definitions, 1 is a new definition. And we'll also try to understand how to identify whether the process is an oxidation process or reduction process based on the change in oxidation state. The old definition of oxidation is it's a process where oxygen is added. Addition of oxygen is called oxidation. Zn plus O2 gives rise to ZnO. Balance it, 2Zn plus O2 gives 2ZnO. You can also ignore the balancing part. Just understand that zinc has added up oxygen to form zinc oxide. It's an oxidation process. The second definition is removal of hydrogen. Now this is generally observed in organic reactions, where if we take CH3, CH2OH as an alcohol, when we say it has undergone oxidation, it converts into CH3, CHO, where one hydrogen has been removed. These are the 2 old definitions. But today most of the reactions involve loss and gain of electrons. So taking that loss and gain of electron into consideration, we define oxidation as a process where electrons are lost or electrons are removed. So the third definition is loss of electrons. We call this as an oxidation process. A species which undergoes oxidation acts as a reducing agent. Let me take the same example of zinc. Zn gives Zn2 plus 2 electrons. Zinc has lost 2 electrons. So the loss of electron implies it's an oxidation process. Zinc is undergoing oxidation. Now taking this as an example, we will try to understand how to identify oxidation process. If from reactant side to product side there is an increase in oxidation state. If from reactant side to product side oxidation state increases, then we say that process is oxidation. Now what is the oxidation state of zinc? 0. 0 is changing to Zn2 plus 2 positive. 0 to 2 plus increase in oxidation state. So zinc is undergoing oxidation. So these are the 4 important points that you need to remember whenever you are discussing about oxidation. In organic chemistry, you come across the concept where alkanes converting into alcohols is an oxidation process. Alcohols converting into aldehydes, aldehydes converting into carboxylic acids, we call that as an oxidation process. When we solve those category of questions, we'll discuss it in more depth. The second thing that you need to understand now is what is meant by reduction. Now again here too we have the 4 definitions, of which 2 are old definitions. Fourth one is not a definition, but fourth one is understanding whether we can identify the reduction process with the help of change in oxidation state. So there we called oxidation as a process of addition of oxygen. Here we say reduction is a process where hydrogen is added. We can take organic reaction as an example. CH3 CHO converts into CH3 CH2OH. The same example which we have taken there, alcohol converting into aldehyde is an oxidation process. Aldehyde converting back into alcohol is a reduction process. The second one is removal of oxygen. Exactly the opposite definitions. Now we have taken zinc oxide there. Zinc oxide converts into Zn plus half O2. This can be taken as an example of where the oxygen is removed. Removal of oxygen. The third definition is based on the electrons. We said oxidation is a process of the loss of electrons. Here reduction is a process of gain of electrons. Let us take the same example. Zn2 plus 2 electrons convert into Zn. Now there we learned that 0 oxidation state is changing to plus 2. Increase in oxidation state is oxidation. Now here we find that plus 2 is changing to 0. Sir, how can you say plus 2 is changing to 0? Oxidation state of zinc here is plus 2. Oxidation state of an atom in its elemental form or in its molecular form is 0. So zinc in the product side is 0. Zinc on the reactant side is 2 plus. 2 plus is changing to 0. There is a decrease in oxidation state. So decrease in oxidation state from the reactant side to product side we say is a reduction process. Taking those concepts into consideration, let us solve the first one. What is the oxidation state of hydrogen here? 0, because hydrogen is in its molecular form. What is the oxidation state of chlorine here? 0. This also is in its molecular form. What is the oxidation state of hydrogen? Plus 1. What is the oxidation state of chlorine? Minus 1. On what basis we are telling this? We discussed whenever hydrogen is attached to non-metal, it is plus 1. Whenever chlorine is considered as chloride or whenever halogens are considered as halides, oxidation state is minus 1. So 0 is changing to plus 1, 0 is changing to minus 1. Implies one of them is undergoing oxidation, another one is undergoing reduction. So here H2 is converting into H plus, Cl2 is converting into Cl minus, implies it's an example of redox reaction. Look at the next one. Barium chloride plus sodium sulfate gives barium sulfate plus NaCl. Oxidation state of barium in barium chloride 2 plus. Product side also 2 plus. Chlorine remains as chloride. Chloride on the reactant side, chloride on the product side. Sodium oxidation state on the reactant side. Sodium oxidation state on the reactant side plus 1. Sodium oxidation state on the product side plus 1. Sulfate as a whole is minus 2. Sulfate is not changing. On the whole it is minus 2. This is an example of precipitation reaction because barium sulfate that is formed is a precipitate. In a precipitation reaction, you just find exchange of ions and there is no change in the oxidation state. When there is no change in oxidation state, it implies the reaction is not a redox reaction. So here when we talk of the redox reactions, redox reaction is a process where there is reduction as well as oxidation. In this reaction, it's an example of precipitation where there is no reduction nor oxidation. Let us look at the next one. On the reactant side, we have zinc and copper sulfate. Zinc is in its elemental form, oxidation state is 0. On the product side, zinc is converting into zinc sulfate where Zn exhibits an oxidation state of +2. So zinc is changing from 0 to +2, implies there is an increase in oxidation state. It is undergoing oxidation. Now copper on the reactant side is +2. Copper on the product side is 0. That implies Cu is changing from +2 oxidation state to 0. There is a decrease in oxidation state. It's undergoing reduction. So zinc undergoes oxidation, copper ions undergo reduction. Therefore, this is also an example of redox reaction. Now let us look at the last option that is given. We can directly take one of them as an example. Iodine. Iodine is in its molecular state. Oxidation state is 0. Here iodine is changing to IO3. Here oxidation state of iodine is +5. Sir, how +5, sir? Recollect the previous question where we learnt about the calculation of oxidation state. X, let X be the oxidation state of iodine. So here potassium is an alkali metal. Alkali metal is +1. Iodine is X. Oxygen is -2. 3 into -2. Because it's a neutral molecule, the sum of the oxidation state should be 0. So this is 1 plus X. 3 into -2 is -6, that is equal to 0. X minus 5, that is equal to 0. X is equal to +5. So oxidation state of iodine is +5. Now 0 is changing to +5. There is an increase in oxidation state, implies it is undergoing oxidation. If one species undergoes oxidation, there should be another species undergoing reduction. Here chlorine is 0 oxidation state because it is in its molecular form. Here chlorine will be in +5 oxidation state, +5 to 0, decrease in oxidation state. So here chlorine is undergoing reduction. Now what will be the options? The option will be second option, because the second option says that it's a precipitation reaction, it is not a redox reaction. So among the given option, which of the reaction is not a redox reaction? The answer is second option. So students, this concept should help you to understand how to identify whether the given reaction is a redox reaction or not. We'll come with another question and another concept in the next episode. Take care. Bye-bye.